Welcome everybody. We've had a couple weeks of a break from the water cooler, but Kevin came on board to wow us all after our break, and he's going to talk about the air quality and tempo mission. Is it tempo? Tempo? Temp.
Yeah.
Tempo. Tempo.
Well, I'm not going to say much about tempo actually. So Erica, you could help fill us in if you have some information. It was kind of one of these things where I said, yeah, I'll give a talk. And that was about 3 months ago. And then last night I was like, oh, I have a talk tomorrow.
I'd be happy to fill in any tempo information.
That'd be great. All right. So more or less, I'm going to talk about like when we have this air quality group. We're doing stuff with small sensors. So here's kind of the group. People I see David Morwell around online, Sarah. It's part of the Global Mission Earth project. So yeah, you guys all know all this stuff probably, right? The sources of air pollution, trucks idling, even buses. That's a new one. Schools are concerned about the school buses idling. How does that affect air pollution? And then they have natural ones down here, and of course, wildfires. Forest fires may not be considered natural necessarily, so because they could be caused by humans. And then we are focused more on particulate matter, PM 2.5. And the reason for that is that any particle that's 2.5 micrometers or smaller can get down in your lungs pretty far. And then you see there's this range there, the ultra fine particles, I guess, can get into your circulatory system, right through your lungs and into your blood. And so here are some of the health impacts from air pollution. My father-in-law, I think he still has pneumonia, so he's recovering from that. He's 83. That's always a challenge. Let's see here. All right, so now I want to talk. There's also different kinds of pollution. So in the 60s, Time magazine had this cover of Los Angeles. I think Los Angeles, and this was smog. So smog is different than particulate matter. So smog is photochemical things. So photo meaning the sun, chemical like chemicals in the atmosphere. So things like organic carbons, volatile organic carbons coming from car exhaust. Getting photolyzed and producing ozone basically. And so the ozone turns into smog, or is smog, and cut down on visibility quite a bit. But then we had catalytic converters came on and cleaned that up quite a bit. And so I did want to show this. So here's ozone in parts per billion on the y-axis, and over time on the x-axis you see Los Angeles coming down, even Mexico City came down. So the pollution in these cities was high for ozone. Like I said, we're going to focus in on the PM 2.5, which is the particulate matter. And so this is my tempo stuff, right? So tempo, it's a geostationary satellite. So it stays over one location, similar to your direct TV satellites and that type of thing, the GOES weather satellites. And so now that can change the way we observe quality. Because we will have hourly observations, and that's important because air pollution changes greatly over time throughout the day. So that's a big improvement. It will be, and also the spatial resolution is much better than some of the other sensors that have been up there. Like here's Washington D.C. You can see you can get maybe a couple blocks, 5 blocks per pixel, versus all of Washington D.C. So this will be a big improvement. Tempo was successfully launched April 7th. As far as I know, there's no data coming yet. Well, we can't see it, right? It's not being released. It's being checked out, all that good stuff. So we're looking forward to getting some data and seeing what that is like. But, and I'll just say Tempo is part of a constellation or several satellites in Europe. They have Sentinel-4 and then GEMS from South Korea. And these satellites all kind of do the same thing. one of my students, GT, is looking at air quality in Bangladesh, and she's trying to use the GEMS data. So it's kind of a experiment to see how it might work to use tempo data, because it's very similar, I think, or will be. All right, so we are really focused on the purple air sensors. So these are small sensors. Margaret Pippin did all kinds of testing over the last few years with her interns to see, what sensors work well. And the purple air, according to her, works pretty well. And green is better than red. So you kind of usually, those are good color schemes. If it's red, be concerned. All right, so here's a question for everybody. And you can put it in the chat. And your answer. Let's see, this is those waterfall things, right? So everybody types it in, and then we count down, you push. What is one of the worst days for air quality in the year in the United States? What day of the year has really bad air quality? Okay. Oh yeah, I didn't do the waterfall thing, but people are putting answers in the chat, so that's good. That works. All right, so we have a couple 4th of July's. Todd, just to be different, put Memorial Day since that was this week. Okay, the summer solstice, June 21st. All right. Day before Thanksgiving. Could be, yeah. Traveling, a lot of traveling going on. When the farms are going, yeah, I was driving back from a soccer game last week, and there's just plumes of dust in the air. And I was looking around on this country road. Oh, where is the tractor producing all this dust? It was just hanging in the air. And then I noticed there's a police car behind me. Whoops. I wasn't paying attention to what was going on. And the police car, the person did not pull me over. So it was good. All right, so we'll go back here. Yeah, 4th of July, Independence Day, but the fireworks is one of the worst days. No, let's see. Okay. So here's we had some students last year collecting purple air data, from the website, and here's like one of the hours right across the country. Not everywhere, of course. Oh, of course, my internet connection is unstable now. So if I cut out, please let me know. All right, so I think again this year we're going to look at this 4th of July with some of our students from the SEAS program. So SEAS is one of the science activation funded projects. Yeah, I could do that. That's a good idea. Do that. And we're going to look at this air quality around 4th of July again. One of the students in Toledo found it was actually a week before, like June 28th, had a higher levels of air pollution in our region than the 4th of July. For some reason, we don't know why, but it can, go up and down, all that good stuff. Let's see. Okay. Oh, and just to show you, Europe did not, and Africa did not have these high values, South America, so I did a wider view. All right, so I just want to show you some examples of things that purple air could be used for. So when the train derailment happened in East Palestine, one of my colleagues said she heard you had to replace all the soil in your yard because of contamination. And I thought, well, that's kind of strange, from the pollution from the plume, the fire and stuff. And so I was able to go on the Purple Air website, and you can see east of East Palestine, this station here, Portersville. You can see the spike, and that was the Friday of the derailment. And it had the huge spike in particulate matter from the smoke from the derailment. But when I looked at the other sites in other directions, they did not have the spike. So what that told me, we had a west wind, and it blew the smoke towards this Portersville. So here in Toledo, we didn't have to worry about the smoke contaminating the soil. So I was able to reassure my colleague that no, the soil is not contaminated from that train derailment. The other thing that's interesting is you didn't see when they did that controlled burn, there wasn't the same spike in particulate matter for that location. And I looked also around at the other ones. There wasn't really a big spike when they did that controlled burn. I thought that was interesting. So that the big impact was from the derailment itself. All right, so I'm going to give it another example. We had, this is a time there was smoke coming from California in 2021, and it's covering North Dakota, Minnesota, etc. But Margaret Pippin and I had worked with, I think it was North Dakota Space Grant, and they worked with schools. And before we did this, there was only one purple air sensor in North Dakota. And then after we did the teacher professional development, all of these schools had purple air sensors. So it populated the state somewhat. And you can see how at the surface, there were kind of bad air quality to the northwest side of North Dakota, but on the southeast side, the air quality was good. Even though if we go back to our satellite image, it showed smoke over the entire state. So it was a kind of an interesting situation. You could see the plume coming from California and Washington State up towards North Dakota. So what was going on? So if we look at the surface winds, this was from windy.com. There was a front right here across the state, kind of see with the blue, south and southeast winds on the east side of the state, and actually northeast winds on the northwest side of the state. So it's actually kind of bringing the plume down to the surface a little bit. Now, Margaret did this. She used high split model to look at back trajectories. See if I can figure these out. All right, so this is North Dakota, northwest side of the state. And then I'm trying to move the chat box around. Oh, I just made it huge. Oh, even huger. Goodness. Okay, so at 1,500 meters, the green line, the wind was coming directly from the west to this location, but then more at the surface, it was coming from the north. All right, and that's where you had it at the surface, the smoke. And then on the eastern side of the state, you had this wind coming from the south. So you can see how at different trajectories caused the different air pollution at different levels in the atmosphere. All right, here's another question. This is at Margaret Pippin's house. Was it May 23rd, 22nd, evening of the 22nd. Look at this big spike here, particulate matter. What caused that? So I'm looking for some guesses in the chat. Okay, we got a couple of guesses. Janine said an error. That's always a good thought. Is it good data? Fire pit, fire, front came through, gardening, auto traffic, grill. All right, so those are our answers we have. So, a smoker right next to the sensor. That would do it, right? So in this case, it was actually, and this is a picture I just took off the internet. It was a charcoal grill. So Margaret was grilling hot dogs. So, and it caused that huge spike. I mean, it's pretty impressive. Let's see if I can go back a second. Look at it again. Well, it was the 22nd. So what's that? Is that Memorial Day? I don't even remember anymore. Okay, so that your grill can really put off a lot of particulate matter. And people have been starting to look at indoor, like using a gas stove, and that puts off a lot of particulate matter too. Now this was like last week. There was the fires up in Alberta. They're still going. And you see the bad air quality coming down in South Dakota, Nebraska, North Dakota. But here in the Michigan, Ohio area, air quality was pretty good. Although our skies were like milk, you know, it was really white, and that was the smoke above the surface. So the smoke wasn't getting down to the surface. A few days later, there was actually a cold front here where you see the dividing line. And when that came through it, it brought some of the smoke came down to the surface. So, I mean, this is a very active thing. So something else we're doing, so switching gears a bit here, we're trying to look at other sensors. And one is Davis AirLink. And this is a comparison, I think it's at my house, because I have an AirLink and a Purple Air. And you can see they track pretty well together. Some of the Davis had higher peaks here than the Purple Air for a little bit, for a while. Oh, there's something in the chat that's long to read. Okay, so the bees didn't come back because of smoke. That's amazing. All right, and then Morwell, he's on the call, is his instructions for and has worked on how to build these air quality sensors. So that's another source of information. You can build them, and we have instructions now, and he's done comparisons between the Purple Air, I think that's Department of Environmental Quality sensor, and then the one his students build. And here's the data between his sensor and the expensive $5,000 one. And they track pretty well together. Some of the peaks are, aren't as good. PM 2.5 is better than PM 10. So that's something we think we're going to have students work on this summer. So, in Globe, of course, we want to have students doing projects. I think everybody knows that in this group. And why do we do that? Here's the AGU meeting, and the scientists share using posters. So why don't we make sure we have students sharing through posters? What's interesting now, AGU has this Bright Stars program, and middle and high school students can go to AGU or virtually. They can do it virtually. And we do have some Globe students that have gone to AGU and presented their Globe projects. It's pretty cool. Here's some examples of some Globe projects. This student was looking, or these students were looking at the Bronx versus Manhattan. And I guess the Bronx get all the things that would produce bad air quality, and Manhattan doesn't. And it's probably because the people in Manhattan have more money than people in the Bronx. You can see over a short period of time that did that matched that way. And then this is one of Janine's students did a project. I think this was, with trees or without trees. And I think it was using the sticky paper up in the atmosphere activity. All right, so I want to switch another gear and show you some of the NASA Langley materials. So there's on the Globe website, there is an air quality science page you can go to. And then My NASA Data has mini lessons. Actually, maybe it'd be good to have everybody go to that and look at it. And then there's also a story map for air quality, but I was having some trouble in some of the E's for the 5E model to get them to show up and load on my computer. I'm not sure if that's a glitch. This was, I think, fairly recently sent out. So here's some of our contact information. And I'll stop my sharing. Put some of those links in the chat, I think.
So I would like to make a comment about the NASA teacher lessons. We have a teacher that each student does a project in her class. And one student, Tyree, who Kevin mentioned about the fireworks, that he got the idea from a lesson. I showed him the teacher lesson. I said, well, read the teacher lesson, follow the directions to get some idea what you need to do. And that's what he did. I never thought of it until this year, but a lot of the high school students could do the same thing. If you show them the website, tell them to read the lesson and see if they can come up with an idea.
Any questions for Kevin?
Or anybody else on the call that knows more about air quality than I do.
Well, I'm wondering, since we have Janine here, I kind of want to put her on the spot because that was her student project you showed. Maybe she could talk a little bit about that project.
The purple air map.
It was the sticky grids, Kelly Wolbald.
Oh, okay. Kelly is actually a junior this year. That project was from a couple of years ago, so I'm not sure. But she probably, I think if I remember correctly, she lives near a really big cornfield. And so she put her sticky traps out near, like right out in the middle of this cornfield that after it had been plowed. And she also put them in a wooded area and in like her front yard. So she picked two like different areas, but they were all pretty close to her house in a like a rural area. She just collected data, I think, for like a week and used the sticky traps and then used the dice and the grid to count the aerosols. And then we did something similar this year where the kids did the sticky traps again, but they looked at different wind directions. So they put the sticky traps out facing different directions. And that was kind of a fun project for them to do. And then also I did a purple air activity where because the kids are not in school over the 4th of July, I took screenshots every hour through the evening while the fireworks were going off. And then I took the pictures, the screenshots that I had made to like someone at my school that has more capability with the copy machine and stuff than I do. And he blew them up and made these color posters. And I put them around the room like in order time-wise and had the kids look at the progression of the aerosols as the evening went on, and the fireworks were like released at different times in different time zones.
Right. Maybe we could hear more about tempo from Erica.
Sure. Yeah, absolutely. So Tempo just launched. It actually, if you saw my note, it's actually turning on next week. And we can start to expect data midsummer. Early data, we'll have first light. And then it'll be a few months before the data is really publicly available. Next spring is really when data will regularly be available to the public. In the meantime, we are hoping to build some interfaces to make that data access really easy. So to support these projects that you all are doing, there'll be various interfaces. We hope to have an app and over long-term educational interfaces for the data. It will also be in various NASA interfaces as well. But we know there's lots of data in those and they can get, there's too many choices in some of the NASA choices. So that data will be available in the spring. It's a number of air quality constituents. So low Earth ozone, so ground level ozone, nitrogen oxides, formaldehyde, things called volatile organic compounds, so things that are put off by nature and human pollution. And like Kevin said, that's hourly data, which is really exciting. So you can you'll be able to track things like these wildfires as they move across the country. You can also track rush hour traffic if that's of interest. There's lots of opportunities to incorporate the data into projects that you all were just talking about, these various projects. You can, the data will be available in perpetuity, so you can look back at over years at 4th of July's over time. And would be remiss if I didn't mention, we are working with Anne and the South Dakota Discovery Center to develop more resources to help support teens engaging in their own air quality investigations. We'll be launching some of those resources in the fall that support young people and how to use the tempo data. For their projects. That's kind of a quick tempo overview. But South Dakota is doing some great stuff to kind of connect tempo with Globe for us.
And I
Hey,
just want,
Erika, I've got a question for you. So we are receiving the Pandora instrument from NASA probably this summer. How is the Pandora instrument? Is it, we want to use it for air quality monitoring, but I understand there's a connection between Pandora and the Tempo satellite, right?
There is, yeah. So there's a Pandora network doing ground truthing for tempo. And that's who's running the ground truthing? I think University of Alabama is helping to run that. There's a couple groups. I can certainly find you some connections if you want to be part of that network. But yeah, so the Pandoras are helping, right? So Tempo is a satellite 10,000 miles above Earth. We've got, it's a spectrometer, so it's measuring light. So
Okay.
we've got all these algorithms that will help us understand what that light is telling us about what's in our air, but to make sure that our instrument is working appropriately and that our algorithms are working appropriately. There's a network of Pandoras and other missions to help us make sure that are measuring here on Earth that help us ensure that our data is
Okay,
accurate.
cool. Cool.
Erica is also my hookup for the ozone tolerant and sensitive and tolerant beans. So still haven't had much success with the milkweed. It's living in our freezer at the Discovery Center. So we're going to give it a good call, a good long freeze. But those of you who've been around for a while, and I think it's been most of us, at the annual meeting in Estes Park, we went out to Rocky Mountain National Park and saw their ozone garden, and which was lovely. So thank you, Erica. And we have our beans planted out front, and our volunteer got really excited and planted all the beans. So now we have a lot of bean plants.
Well, if you need a second later in the summer bash, let me know.
Okay, yeah.
And we're always happy to expand the Ozone Garden Network. So if anybody's interested in joining that, please let me know. I can put my email in here in the chat as well. There's some citizen science efforts there as well that you can contribute to.
Which,
Thank you, Erica. Oh, sorry, Ann.
yeah,
go
I
ahead.
was like, what is the ozone protocol still part of the Globe protocols, or was that sunset?
I think it looked like it was sunset. Mike was like, no.
I know
Yeah.
Margaret worked really hard, but I think they're a little difficult for the Globe protocols. But that doesn't mean they're, could always be a comeback.
Yeah, the ozone gardens are a good way to do it. Good connection to Globe.
Yeah, Erica, it's great to have you here joining us. Thank you, Anne, for bringing her, and I hope we didn't scare her off.
Not at all. And actually,
Oh, go
Jen,
ahead.
I'm a UNH alumni, so.
You are?
Yeah.
Oh, well, it's awesome to meet you then and to connect. I didn't know that. Huh. Okay, good. Let's see. It's CSA last week. Air quality using spider webs. Oh, that's cool. Huh. Okay. Madeleine, I think we need to hear more about that.
I know. So the person's name is Chris Hahn, and they go by they, them. They wanted to learn more. Let me turn on my camera. I'm sorry. Work with the community. So Chris is part of the science paper that just came out. I'm sorry. That just came out about accessibility and having a citizen science project that says anybody can participate, but actually allowing anybody to participate, right? So Chris worked with the community on how to change the protocol without risking the data quality or the purpose of it. And so the community grabs these spider webs, and Chris is able to pull out air quality information out of them, which I think is brilliant. So as right now, since I'm part of the science working group in Globe, I'm gonna talk more to Chris and see how Globe can learn from this process, because I've heard from other communities saying that some of the protocols are not very accessible. And so it'll be interesting. So as I learn more from Chris, I'll be able to reach out as well. And then my other message is WMO reached out again. So that's the World Meteorological Organization, because there was a big dust storm in Illinois that killed a few people. They've been wanting to use Globe. They've been actually using Globe clouds data, because you can report a dust storm and take a photograph. So if you can promote that to people, and again, these are dust storms in areas you would not expect. So this was Illinois, because of what Kevin was just talking about, all these things that can cause bad air quality data. So
it's interesting the number of protocols that I'm reminded of that we can use to look at air quality. I mean, every once in a while I forget, right? And but it shows up in the clouds, in the color of the sky. So not just on the purple air, right, sensors. Do you have, I was wondering, do we have one of the, a pacing guide for air quality? I was just thinking though, or at least like a differentiation, right?
Good question.
Sorry, go ahead. I was just thinking.
No, I think, I don't know.
It would just be interesting, right? If we said studying air quality K-4 at this grade level, this is the protocol you want to use.
So
And
we
then at
kind of
this
did
grade
that.
level- Okay.
So what Kevin showed was kind of the start of that. So Angie Reese really led that.
They're called learning progressions.
Right. One thing is the learning progressions, and the other thing is what we came up of using the cloud portion to use
Right.
in air quality. So when you go to the air quality, it's kind of divided, and we also divided up the types of projects. Jen, like you're talking about K4, 5 through 8, 9 through 12. We might want to revisit and see how, if it needs to be packaged up a little bit better, but it is out there little by little. We worked on it.
And I just bring this up because I was actually asked how people could study what it looked like to study carbon cycle things at the elementary level. And I said, let's not. But there are Globe protocols that would play into, if we're thinking about the spiral of the carbon cycle, there's things at the elementary level that you could do that could then support it later on. And so I'm just thinking, how many things like that do we have already in Globe that people have worked on? And it would just be really interesting to see if we can think about things as a spiral like that. And so the air quality is one of the ones that I think would be a really interesting one. Because also thinking about pairing older students with younger students, right? So they're using maybe the purple air, but then they're going into a second grade classroom and talking about air quality and teaching them how to use sky color or clouds. Anyway, I'm getting off track. Anybody
Well,
have
we,
done that?
we had a kindergartner use the up in the atmosphere, up in the air sticky paper. And then he got MODIS data and compared it to the MODIS air quality data as a kindergartner. And we keep seeing him. He came to our conference this year as a 7th grader now. So he's been doing stuff for 8 years with us. The other thing I wanted to mention is, air quality, we have the Cala2 is a globe protocol. And then as was mentioned, ozone's been sunsetted. You can use sky color and visibility. But, that those are the question, how do you have a student do air quality project made with purple air and then relate it to globe? And we had a student in the rural area, he wanted to find out if the buses produce a lot particulate matter. And so he looked at the purple air at the school, and the data didn't show what he thought. He thought it would be high in the morning, high in the afternoon. And some days had that, but other days had high in the middle of the day. And I said to him, well, maybe it depends on wind speed and wind direction as well. So he then, Globe has these weather stations, right? We have the Davis weather stations. You can get wind speed. I'm not sure if you can get direction from those weather stations. So he was able to put that together. Right. So, yeah, because the weather affects these things a lot. But that was, kind of a eye-opening for many students. It's just learning about the weather and how much it affects air quality or, clouds, how that affects temperature, et cetera.
All right, any other questions? No, my mind is spinning though. I don't know if anybody saw our phenology resources. We tried to put together all the learning activities. We put them together by grade level. We added some books in there. And I'm just wondering if something like that would be helpful for air quality, to kind of put everything together. I don't know. Do you think that's helpful? Would that be helpful to Globe partners? Would it be helpful to Globe teachers if they're teaching multiple grades?
We always get this from our teachers. They don't understand how NASA is tied into Globe and Globe is tied into NASA. This is my opinion, if we could get on the same protocol page, let's say the aerosol, the links to my NASA data that would be appropriate, or at least refer the person to look in the My NASA data resources, because that's not always evident. That's something we try to do in our Globe Mission Earth webpage, is to marry the two. I think that would help in some cases when teachers, like we've been talking, their students have these ideas, but the teachers don't know even to think about NASA. And people will think about NASA, but not think about Globe.
I think, yes, you raise definitely a good point.
Our teachers always think of them as two different things, but they're really one and the same. They're nested. And so that's the one point we try to tell our teachers, that you merge both together.
Yeah, it's hard from a web design perspective because they have their own standalone, very large website with a search engine and organization and everything, and so does Globe. and also so does Globe Mission Earth. So we've contemplated doing something like that on our Mission Earth page, but then it just turns into a recreation of what they've already done on their own page. So then we just end up coming to the conclusion of, well, let's just link to their page. So always hit
Well,
that.
it could be linked to their page with a brief description,
Yeah, that's what we do.
but it's not on the Globe main page. Or if it is, I haven't seen it.
Right. It's on Mission
That's-
Earth, but not on Globe. Right.
Right, not on Globe
Okay.
as a whole.
Mhm.
All right, so things to contemplate in the future is how to link these two together. I did put the link to our resources for the Green Down campaign that we put together, right? So we just kind of scoured the Globe website and put all the different things together that kind of fit under that were scattered. But this is under our fall campaign that we're doing. So this is a little bit different, but it could be used probably for something similar too. Okay. So any other comments, questions, things for the greater good? We have 1 minute, so there's not much time. And what we have coming up in a few weeks is John Riskey has some an awesome project from GeoPaths, and that is going to be on accessibility. And he's doing some really cool stuff. So definitely something to come and listen to and ask him questions about, because he's just started this project. And it's basically making the field season accessible. And Kevin, thank you for the awesome review of air quality, and so that I can start thinking about that again, and in a little more depth. There's a lot of good stuff with that. And I love looking at, it's like a mystery every time I look at those maps, right? It's what is happening? Where's the fire? Or the fireworks, or where are the hot
Right.
dogs burning? And with that, it is 5 o'clock here and dinner time in the Northeast. So I'm gonna go see where my hot dogs are gonna start smoking on the grill. Or the Impossible Burgers maybe tonight. Thanks everyone for coming, and have a great rest of the week. And I hope that everyone had a great holiday weekend as well, and some rested up a little bit. So, and Erica, come back anytime.
I will.
All right, everyone, and get on focus group it. We'd love to have your thoughts on that. So, bye everyone.
Bye-bye.
Thanks, Jen.
Bye.
Bye.